So I want to talk about a few things from the Principles and Practices of Commercial Construction book. Once again, this is one of these books that you cannot take in, which it makes it that much more
I think
challenging.
they let me have it on the last test.
Say again?
I said they let me have it on the last test.
They weren't supposed to. They
Yeah.
weren't supposed to. You got lucky if they let you bring this in.
I didn't really use it though.
Yeah. I want you to find, the first thing I want to talk about is tilt-up construction, and that should be on page 277. 277, tilt-up construction. Okay. You've probably driven by construction sites and seen this, or maybe you've worked on it yourself. It says on page 277, tilt-up load-bearing wall panels. Tilt-up construction is a technique for producing precast wall panels for 1- or 2-story buildings at the job site, rather than in a precast plant. Originally developed for economic reasons, improvements have made it possible to produce panels that are also architecturally pleasing. Okay, so the first time we see this word is panels is there. Load-bearing panels may be produced by this system and function, same as load-bearing. There are 3 common types of panels, okay, and so forth. Next sentence. Panels intended to carry pre-stressed loose slabs are cast with continuous ledger near the top edge. Okay, so, and then it says panels again in the next sentence. So there is a good chance that panelized, the word panelized, will be used when describing tilt-up construction. Okay, so that's the first thing I want you to know. Okay, so keep that in mind. Panelized construction, tilt-up is done with panels, panelized construction. Okay, I want you to jump over to page 400. Okay. On page 400, we have curtain walls. All right, there's a discussion of curtain walls on page 400. Curtain wall construction, first sentence, the development of steel and structural and concrete structural frames for multi-story buildings has led to the adoption of non-load-bearing exterior walls known as curtain walls. Their primary function are to protect the interior of the building from the elements and to enhance its appearance. So that's what you want to know. You want to know that a curtain wall is non-bearing. Okay, it's just up there, protect the interior of the building and for what do you call it, and enhance it and enhance its appearance. Okay, so know that about a curtain wall. Okay, on page 201, I want you to know a little concept about called a flying 201. Okay. Flying form. Okay, it talks about underneath these diagrams is actually is where you find this information. It's in the caption underneath the diagrams. Flying a form. Okay, first of all, it's rolling out of a bay, suspended, closing a new bay, and so on and so forth. Okay, that's called a flying form. Okay. Says, what is it? It seems like there's more about that. Hmm. Anyway, if you're going to be doing the same, oh, here it is. We back up to page 194. Flying forms. In many present-day high-rise cast-in-place concrete buildings, construction is identical from bay to bay and from floor to floor. That's what's key here. So you don't have to destroy the whole form and start from scratch. You can just take this same form and move it from one section to another. The buildings consist essentially of either a series of columns supporting flat plate or a number of shear walls, a floor slab, designed for one floor can be used on all, reused on the others. The main problem being the moving of the forms from one position to the other. This problem has been solved by the use of flying forms, which are forms designed as a complete unit large enough that the entire floor of any one bay may be cast on it and capable of being moved as a unit from one position to another. That's a flying form. There you go. Okay. Interesting concept on page 311. 311, the structural frame. Okay, page 311. Let's see. There's a concept that I want you to understand called live load and dead load. All right. I specifically remember somebody asking me one time about, they gave me some equipment and some materials and some weights of the materials and so on and so forth. And what they asked me is they asked me about the live load versus the dead load and what was the actual weight. Okay, so what you have to know, there's a couple things you have to know. You have to know what is live load and what is dead load. What are they talking about here? Okay, well, it says on page 311 on this, under the structural frame, the second sentence says the structural frame must be capable of resisting applied loads in various combinations as determined by the structural engineers. Typically, the loads fall into two categories. You have dead loads and live loads. Included in the dead load category are the materials used in the construction of the building, okay, including the weight of the framing members. Stationary equipment and permanent partitions are also considered dead loads. So dead loads, you have to think about dead loads being anything that's part of the structure. If it's part of the structure, if it's permanent, relatively, it's going to be a dead load. A live load includes gravity loads, occupancy. Okay, people are alive. Okay, great. They're live loads. The weight of stored material. Okay, this isn't part of the building. It's just stuff stored, so it can be moved. It's a live load. Snow, rain, movable equipment, anything that can be that is generally moved around. Other live loads such as wind or earthquake pressure due to backflow hydrogen. So basically what you have to say is anything that's part of the structure is a dead load. Anything that's not a part of the structure is a live load. So the question that somebody asked me one time, it gave me a bunch of timbers as well. And it said that wood weighs X number of pounds per board foot. Okay, so now we're looking at board feet. Well, how do we know how to figure board feet? Well, real quickly, let me show you about board feet.
Oh, that's the width times the height times the length divided by 12.
That is right. When you're talking about structural members, okay, real quick. Let me just kind of go down through here and see if I can find it. It's called board feet of measure. We was an approach. Board feet of measure. Where you at, baby? Where you at? Roof. And that's not it. Sorry. One more time. Board feet of measure. The thing about board feet of measure that is sometimes so hard to remember is that you only, when you're doing board feet of measure, you're not doing the actual size of the board, you're doing what they call the board. So if it's a 2x4, it's 2 times 4 by whatever length it is. So I can't find it right now, but it is you were right about that. It's the size of the board. So if it's a 2x4, it's 2 times 4 times the length divided by 12. That's your board feet of measure. Very good. So they're going to give you some structural members like that. They're going to say that's part of the building. You're going to have to figure out how much it weighs. And then you're going to have to add a bunch of stuff together, the different stuff they give you. And you're going to have to understand the difference between dead load and live load in that question right there. Not a big deal. But it's just some stuff you got to know. Okay, so we're going to add a couple more things that I want to highlight that I want to make sure that you can find in this book. It's on page 34 and 35. 34 and 35. So we go back to 34 and 35. So we're doing some elevations here. All right, so we're doing some surveying, doing some elevations and so on and so forth. So on page 34, at the bottom right, there is something called a theodolite. And it says the telescope on a theodolite may be rotated 360 degrees in a vertical plane. The instrument is designed primarily for measuring horizontal and vertical angles. Consequently, the graduations on the scales are finer, providing for greater. So the bottom line here, though, what's really important.
That one was on business and finance.
Okay, so it's 300. The theodolite is rotated 360 degrees vertically and horizontally. That's what you got to know, and that's going to take you through all the important information that actually let's do a couple more things. Got a couple. Let's look at a couple things. We're looking at. I just saw some stuff that. Let's look at 76. Look at page 76. Page 76. Okay. All right. Well, I want you to find something called a Payline. Page 76. I want to say 71. Before an excavation begun, its cost must be estimated. Yeah, no kidding. The estimate is based on cubic yards. Plans show an area occupied in certain soil type, size, okay, so forth. However, additional space is sometimes required so that forms can be constructed, and to be able to work around the outside of the forms excavation, a line is drawn at a reasonable distance, usually 2 feet outside the building line, and the excavating contractor is paid for the material excavated to this line called the pay line. So the pay line is that area that you have to dig that has to be excavated. And the reason it's called the pay line is the excavator is paid to dig that. Okay. They're not just paid for the size of the building, they're paid to the pay line because it has to be excavated. Okay. And so see if you remember what pay line means. 233, page 233. We're talking about concrete here. We're talking about pumps. And we're talking about underwater. Okay, 233. There's 3 types of pumps. First of all, I'll talk about 3 types of pumps. First thing on page 232, concrete pumps are used to transfer concrete under pressure through some type of piping system. Pumps are of 3 types: piston, pneumatic, and squeeze pressure. All right. It gives us a little bit about all those. And the next thing we have is there's a definition. There's something called underwater concreting on page 236, right-hand column. Underwater concreting. Okay. And the second paragraph discusses something called a tremie, T-R-E-M-I-E. One of the most widely used methods of placing concrete underwater is by the use of a tremie. This is a pipe with a normal diameter 8 times the maximum size of the coarse aggregate and the concrete being used. It is commonly made in 10 and 12-inch diameters and 10-foot lengths. A funnel-shaped hopper is bolted to the top, bolt together. So it's called a trimming. If you're doing underwater concrete placement, you might want to know that. Okay, 299, just a couple of other things I want you to know. 299 discusses an English bond. I want you to understand this English bond. I want you to take a look at it and see if you can kind of get an idea of what they're doing here. So an English bond almost looks like every other brick is turned at 90 degrees. And then it's alternated from course to course. There you go. English bond. Keep that in mind. Okay, and then on flooring, 394 and 395. 394 and 395. Okay. Epoxy coatings. Bottom right on page 394, epoxy resin is a synthetic that is often used as a bonding agent or repair material in various construction applications. It will also be used as a base and ingredient of floor topping. Okay, you have a liquid resin and a curing agent. All right, 2 types of floor topping can be made with this epoxy, filled or unfilled, kiln dry sulfate, and so on and so forth. Okay. That last paragraph, a synthetic terrazzo topping may be prepared by mixing marble chips and urethanes, acrylics, or epoxies. Coloring can be added and so forth. So you may want to read through that section just to make sure that you know. Occasionally that question might come up about the epoxy flooring. Okay, and that pretty much does it for the principles and practices of commercial construction.